Hi everyone. In this video, we will see how to convert a regular expression into finite automata. So you already know that regular expression is the representative of regular language, and regular language is accepted by a machine called finite automata, and it is generated by a grammar called regular grammar. Okay, so there are both ways conversion possible, means you can convert the regular expression into finite automata, and also you can convert a finite automata into a regular expression. First we will see the conversion of regular expression to finite automata. So there are various rules defined here. We just look at them, look at the rules, and then we will apply the conversion procedure. So first rule is, if a regular expression contain only symbol phi, then you will show them with the help of a circle, and this circle is nothing but initial state. So here in the conversion process, we will just use a state creation method. Okay, state creation method means we create a state for every regular expression or for every symbol present in the regular expression. Okay, so if phi is present, then it will be represented by a state called initial state. Second one is, if let's say input alphabet A, assuming that there are two input alphabet possible, A and B. If input alphabet A is present, then it will be represented by a state, two states. One state is initial state, and this initial state will make a transition to move to the final state by using the input alphabet A. Okay. Now the third one is A union B. If you apply the union between two input alphabets, then you will convert this regular expression by using two different states. One state is initial state and the other one is final state, and the transition will be either A or B. So here I will represent the transition A comma B. Fourth operation is concatenation operation. Concatenation operation is dot. So A dot B. A dot means if any regular expression containing two different input alphabets and the concatenation operation is applied on them, then this will be converted to finite automata by using three different states. One is initial state. On initial state, if you take a transition on input alphabet A, you will go to the second state, and again if you take a transition on input alphabet B, you will go to the final state. Okay, and the last one is very important, clean closure operation, because sometimes it is confusing to remember this clean closure operation. So in clean closure operation, let's say you applied clean closure on input alphabet A. You can also apply clean closure on input alphabet B also, but here I am applying on input alphabet on A. Then this clean closure operation is converted to finite automata by using four different states. From initial state, if you make a transition by using epsilon symbol, you will go to the second state. On second state, you will make a transition on input alphabet A, you will go to the third state, and from the third state, you will make a loop by using the input by using the symbol epsilon. So here loop is generated by using epsilon and A input symbol. And on third state, if you make again epsilon move, then you will go to the final state. Okay, and on final state we directly come back to the initial state by using epsilon moves. Okay, so this is very important, clean closure operation. Clean closure is very important. Okay, and you have to remember this operation, and all the other operations are simple and it is intuitive. By intuition you can draw their different finite automatas. Okay, for example, let's say a regular expression A B star, then what will be the finite automata? The finite automata is initial state, and then after that I will take a move on input alphabet A and go to the final state, and on final state I will make any number of B's. I will take a transition of any number of B's on the final state itself. So this is the finite automata for the regular expression A B star. Okay, So similarly, you can take various regular expression and draw their corresponding finite automata. So it is up to you. uh, Exercise all the different regular expression and convert them into finite automata. In the next video we will see conversion of finite automata to regular expression.